this video, I'm going to discuss about polynomials in the context of CAT preparation. Now, before I start, I want you all to know what are polynomials, and you should also know what is meant by degree of the polynomial. So what is definition of a polynomial? Polynomials are algebraic expressions where every power of the variable or variables is a whole number. For example, if I take the example of x cubed plus 5x squared minus 7x plus 2, we see that in this expression, every power of the variable is a whole number, including the last term, which is 2, because 2 means 2 into x to the power 0, which is also a whole number. Therefore, the entire expression is a polynomial. The next term is 3x squared plus 5x minus 9. This is also a polynomial because every power is a whole number. So our defining criteria is that every power of the variable should be a whole number. The next one is also a polynomial, that is 9x plus 5. However, if we now look at this example, we see that the last term here is plus 2 by x, because of which there is some problem. Now, what is the problem? In case of 2 by x, it is nothing but 2 into x to the power negative 1. And since here the power of x is minus 1, which is not a whole number, so the entire expression ceases to be a polynomial. Similarly, in the next example also, we see that there are two terms where in each the power is negative. For example, 5 by x squared means 5 into x to the power negative 2, and 9 by x means 9 into x to the power negative 1, and both are negative powers, not a whole number, so the entire expression is not at all a polynomial. Look at this example. Here the middle term is 5 into root x. Now when we have root x, it means what? It means the power of x is half. And as we all know, half is also not a whole number. It's a fraction. So it's a rational number, but it is not a whole number. So the expression is not a polynomial. The term degree of a polynomial is defined only if it's a polynomial. The degree means the highest power of the variable in the polynomial. So for example, if I look at the first example, which is x cubed plus 5x squared minus 7x plus 2, the highest power here is 3. So degree is 3. In the second case, the power is 2. Highest power of x is 2, so degree is 2. Obviously, in the third example, the highest power is 1, so degree is 1. In the remaining examples, since none of them is polynomials, so the degree is not defined. One more thing I want you to know is that in the first three examples, since the degree of the first is 3, it is known as cubic polynomial. The degree of the next is 2, so it is known as quadratic polynomial. And the third one is linear polynomial. Now the question arises, is 5 also a polynomial? Which basically means, are constant numbers also polynomials? The answer is, of course, yes. All constants are polynomials. Like in this case, we can see that 5 you can write as 5 into x to the power 0, where power 0 is a whole number. So all constants, therefore, are polynomials known as constant polynomials. And what about degree? Of course, by now we have understood that the degree of the constant polynomials will be nothing else but 0. Is 0 also a polynomial? Yes. And that is specifically known as 0 polynomial. But sadly, the degree of 0 is not defined. Why? You may argue here that 0 you can write as 0 to x to the power 0, and so degree of 0 polynomial should be 0. But actually, if you observe a little more carefully, 0 you can also write as 0 into x to the power 1, or 0 into x to the power 2, or power 3. So that means 0 is the only polynomial which has no degree defined as such. Now we will get down to learning how to divide a polynomial by another polynomial. And I'll take an example to clarify this. First, I'll discuss long division method. And I'm sure you all must have done this method in your school days. So let's divide this polynomial by x minus 2. So we write this main polynomial which I'm going to divide, 2x cubed minus 5x squared plus 6x plus 3. and we write some box, some lines we write, and this polynomial which I'm going to divide is known as dividend polynomial, and by which I'm going to divide, that is x minus 2, that is known as divisor polynomial. Let's start dividing. I should have the first term of the quotient such that that term multiplied by x minus 2 should give me the answer where the first term should become 2x cubed. So obviously I should multiply it with 2x squared. So my first term should be 2x squared. See, if I multiply 2x squared with x minus 2, what I will get? I will get 2x cubed minus 4x squared. Now 2x cubed which I got in the answer, it matches with the first term in the dividend. And later on when I subtract these two polynomials, I will get the first term vanishing. It will become 0. So now I will do subtraction. That means sign reversal will happen. So 2x cubed minus 2x cubed becomes 0. It vanishes. And I'm left with minus 5x squared plus 4x squared, which is minus x squared. And I take down the next term of the dividend, that is plus 6x. And I carry on the process further. So my next term in the quotient polynomial will be minus x, because minus x when I multiply with x minus 2 gives me minus x squared plus 2x. Now again I subtract, sign reversal will happen. I'll get 6x minus 2x, that is 4x. And then I again take down the next term from dividend, that is plus 3. So I get 4x plus 3. And lastly, I'll have plus 4 above, so that 4 into x minus 2 gives me 4x minus 8. Now if I subtract, I'll get sign reversals and I'll finally get 3 plus 8, 11. Now 3 plus 8, 11, this 11 which I've got is called remainder, and the number above which I've got is known as quotient or quotient polynomial. So my quotient is 2x squared minus x plus 4, and this 11 which I got in the end is known as remainder polynomial. So I hope this division process by conventional approach is clear to you. So I can write now that this main polynomial 2x cubed minus 5x squared plus 6x plus 3, which I was calling as dividend, is equal to x minus 2 into brackets 2x squared minus x plus 4 and plus 11. Which means what I'm doing here is dividend is equal to divisor into quotient plus remainder. And this is known as division algorithm. Also, you should note that degree of the quotient. How to get the degree of the quotient? That's always degree of dividend minus degree of divisor. So in this example, we can see degree of the dividend was 3 and degree of the divisor was 1. And so obviously degree of the quotient must be 3 minus 1, that is 2. And that we have just now proved that the degree of the quotient is 2. And degree of remainder is always less than the degree of divisor. In this example, the degree of divisor was 1. So degree of remainder will be less than 1, which means it will be 0. So 11 is a constant number, and we have seen that the constants have degree 0. Now we come to the shortcut method of division process, which is known as synthetic division method. It's a very nice method compared to the conventional approach of division. Now in this, we'll again take the same example just to clarify that we'll get the same answer, and you will also be able to compare the two methods, which one is faster or better. In this method, what I'll do is I'll write the coefficients of dividend individually, but with some space between them. So my coefficients are 2, minus 5, 6, and plus 3, which I have written there below this question and with some space in between them. Then I'll do what? I will draw a vertical line, and I see that divisor is x minus 2, which when equated to 0 gives me x equals to 2. And that 2 I put to the left side of the vertical column like this. And then I start the process. Now, first step is the first coefficient, that is coefficient of x cubed, which is 2 here, is put as it is in the answer 2 below. I repeat, the first coefficient, that is the coefficient of x cubed, which is 2, I put in the answer as it is. Now this obtained answer 2 is multiplied by the left side 2, I'll get 4. 2 into 2, 4. And I'll write it in the next column and add the next column. So I'll have minus 5 plus 4, that is minus 1. Minus 1 I multiply with the left side number 2, which is above. And minus 2 into minus 1 gives me minus 2. And that I put in the third column, the next column. So then I add again, I have 6 minus 2, which is plus 4. 4 multiplies again the same number 2, I'll get 8. And then I do finally 3 plus 8, 11. And this ends the process. Now what do I do? To the left of the last column, I'll write a vertical line. I'll draw a vertical line. And I see that the rightmost answer, that is 11, is my remainder. And the remaining numbers which I got, if I read it from right side by leftwards, that is 4, then minus 1, and plus 2. To them, I'll attach the increasing powers of x. That means with 4, I'll attach x to the power 0. With negative 1, I attach the next power of x, which is x to the power 1. And next one, I attach x to the power 2. And that means what I'll get is 2x squared minus 1x plus 4. And that is the quotient. And as I said, remainder obviously is 11. So I feel that this method is better than the previous one, the conventional method. We'll take some more examples to clarify this further. Now let us divide this number by x minus 3. So as I've already mentioned, we will first write the coefficients with some space. So we have what, 2, minus 3, minus 17, and 35. Divisor is x minus 3, so that is equal to 0. We get x equals to 3. And that 3 I put to the left side of the vertical line. As I have said earlier, that 2 is written as it is in the answer, 2. This 2 is multiplied with 3. 2 into 3 is what? 6. Put it in the next column. Then we have minus 3 plus 6. We have plus 3. 3 into 3 gives me 9. And again, I put in the next column. Add them. We'll get minus 8. Carry on the process. In the end, I will get 11. And so my remainder here is 11. And the quotient is 2x squared plus 3x minus 8. I hope by now the method must be completely clear to you. So we can proceed now. Okay, one more example. In this case, my divisor is x plus 3, which I will, when equate to 0, I'll get x is equal to negative 3. So coefficients are written as it is, and I put minus 3. I'm quickly moving ahead. 2 is kept as it is. 2 into minus 3 is minus 6. 5 minus 6 is minus 1, and so on. You can verify the answers. And finally, I get remainder as what? 54. And my quotient is 2x cubed minus x squared plus 7x minus 14. And remainder is 54. All right. Remainder theorem. It's a very important part of polynomials topic. Now, what does remainder theorem say? As per remainder theorem, when a polynomial fx is divided by x minus a, then remainder is f of a. This I'll elaborate through example. We have to find out the remainder in this given question. So what I'll do is, I'll first see that dividend is 2x cubed minus 5x squared plus 6x plus 3, and my divisor is x. I would want you to recall that dividend is equal to divisor into quotient plus remainder. That means in this case, fx is written as the polynomial that is equal to x minus 2 into some quotient qx and plus remainder r. Now in this equation, what will happen if I put x as 2? So if you put x as 2, we will get 2 into 2 cube minus 5 into 2 square and so on. That is plus 6 into 2 plus 3. But right hand side, you see first term becomes x minus 2, which is 2 minus 2 into qx and plus r. Now 2 minus 2 makes it 0. So 0 into qx, that entire term vanishes. And so that means I'll get r is equal to the left side polynomial where x was put as 2. And so my remainder is this. And what was this expression? This is nothing but the expression when you obtained when you put x as 2. And this gives you sort of a proof also of the remainder theorem with the help of division algorithm formula. Now I think you can solve this question much faster. So our x minus 4, when you put equal to 0, you will get x equal to 4. Putting that 4 in the function, that gives you the remainder. So f of 4 is the remainder, which finally comes out to 0. In this case, since it is coming out to be 0, I can say that the polynomial is divisible by x minus 4. Here I have to find the value of k for this data given. My process remains the same since I'm given the remainder, which is 6, and it says the divisor is x minus 1. So a is 1 here, and when I put 1 in the function, I'll get 1 cube plus k into 1 square and so on. That will be equated to 6 because that's the remainder. And therefore, solving this, I'll get the value of k as 3. Related theorem to remainder theorem is factor theorem. A factor theorem says that when fx is divisible by x minus a, then fa is 0. Isn't that obvious? Because earlier I had said in remainder theorem that when fx is divided by x minus a, my remainder was what? Remainder was fa. But if I'm saying it is divisible, it means remainder will be 0. And if remainder is 0, it means fa will be obviously 0. I have to find a value of k in this question. It's a similar question now. Now my a is minus 2 because x plus 2 equal to 0 gives me x is equal to negative 2. Putting it in the function and equating to 0 gives me the value of k as minus 5 by 4. Now let us see how do we divide this by 2x minus 4. In this, I'll again use division, the synthetic division method, the shortcut method for division. Write the coefficients and then divisor is what? 2x minus 4. It is not usual x minus something. It is 2x minus 4. So I'll equate that to 0. I'll get x is equal to 2, and that 2 is put in the left side. Process is same. This dividends term 2 is kept in the answer first step. That's the first step. That 2 is multiplied with left side 2. I'll get 4, then 5 plus 4 is 9, and process goes on and on. I get finally 114 in the end. Putting a column now, I see that the remainder is apparently 114, and my quotient is what? 2x cubed plus 9x squared plus 22x plus 51. Now my question to all of you is that the answer? Because if you say this is the answer, then what will be your answer if the given polynomial were to be divided by x minus 2 instead of 2x minus 4? Because in that case also a will be 2, which you put into the left side. So will the answer be same even if it is x minus 2, or if it is 2x minus 4, or for that matter, 3x minus 6 and so on? Will there be no change in the answer? Of course, there has to be some catch to this question. Let us explore further. Now this we are sure is the answer when the divisor is x minus 2, as we have learned in the previous examples. So let us do it by division algorithm now, that the dividend is equal to x minus 2 into this obtained quotient and plus remainder 114. This is my exact equation, the correct equation. Now what? This x minus 2 is not my correct divisor as per this given question. To make it correct, what I'll do is I'll multiply the x minus 2 by 2, but that will make the equation unbalanced. To keep it balanced, I will divide the quotient part by 2, so that 2 and 2 cancels, I get back the original equation. Okay, so that means if I change the divisor from x minus 2 to 2x minus 4, I'll have to divide the quotient correspondingly by the same number, that is 2. And that proves that the quotient is this. That is the obtained quotient divided by 2, but remainder remains unaffected. I hope this point is clear to all of you. Again, recall remainder theorem. What was that? That when fx is divided by x minus a, the remainder was f of a. In the light of the previous example, now I can say when fx is divided by ax plus b, what will be the remainder? Like in the previous case, x minus a was divisor. You equate that to 0, you get x equal to a, and that a is put in the function to get the remainder. Similarly, ax plus b, when you equate that to 0, you get x is equal to minus b upon a, which when put in the function should give you the remainder. And that's what we have done. So you can say this is the revised remainder theorem, that remainder is f of minus b upon a. Now comes factorization of higher degree polynomials. For example, if I have a cubic polynomial like this, how do you factorize this? In this, I have to search for some value of x or some natural number or maybe some integer, which when put in the value of x makes the expression's value as 0. And that I will do by some hit and try. Actually, the concept is that if the coefficient of x cube, as in this case, is 1, then look at the last number, which is minus 120. One of the factors, negative or positive factors of 120, should make the entire expression 0. Ideally, this should happen. So 120, the one of the factors of 120 is 1, then we have 2, 3, 4, and 5, and so on. We also have factors as minus 1, minus 2, minus 3, minus 4, and so on. So by hit and trial, we realize that when you put x as 1 in the given function, the function's value becomes 0. And so by factor theorem, I can say that x minus 1 is a factor of fx. And therefore, I can say this dividend is equal to x minus 1 into qx. Obviously, there will be no remainder. Now, to find qx, that is quotient, I'll have to do division of the given polynomial by x minus 1. And I can use synthetic division method. I'll not spend much time on this, as I believe that you are aware of this method now. So 1 as it is, 1 into 1 is 1. Put in next column, we have minus 22, and so on. And it's already proved that finally my remainder is 0. And the quotient becomes x square minus 22x plus 120. Okay. So we have the factorized format as this, but we can still factorize the quadratic function further. So I will get x minus 1 into x minus 10 into x minus 12. Now, how did we do this? You see, the quadratic function is x square minus 22x plus 120. So by middle term splitting method, minus 22 can be split as minus 10x minus 12x. And then factorize further, you will get the final answer as x minus 1 into x minus 10 into x minus 12. Factorize this. Now, this is a fourth degree polynomial, and in this case, I'm also given that two of its zeros are minus root 2 and plus root 2. Zeros of the polynomials means those values which, when put in the value of x, makes the function's value as 0. That means x minus root 2 and x plus root 2 both are the factors of the given polynomial. And so it is, the function is divisible by x minus root 2 into x plus root 2, which I can also write as x square minus 2. So now I cannot use synthetic division method. So what I'll do is I'll divide by normal conventional method. I'll get the quotient as this. I believe you know how to do by the division process by conventional methods, so I have not elaborated it here. So once you get the quotient as 2x square minus 3x plus 1, you can do again middle term splitting to finally get the factorization as x square minus 2 into 2x minus 1 into x minus 1, which finally becomes x minus root 2 into x plus root 2 into 2x minus 1 into x minus 1. So basically, we are able to identify in this question that x square minus 2 was a factor of the given polynomial, and by division, I was able to get a quadratic quotient polynomial, and which I can factorize further by middle term splitting. These are the examples which clearly shows to all of you as to how to factorize cubic or higher degree polynomials. Now we have come to the stage of discussing application-based problems based on whatever concepts we have covered in the polynomials chapter today. Let's get started. Our first example is find this remainder when you divide this polynomial by this quadratic polynomial. So one of the easiest ways will be that just divide directly by the conventional method. We can't use synthetic method here. That is one method. But if I have to find out some other method, what do? We realize that the divisor x square minus 5x plus 6 can be factorized as x minus 2 into x minus 3. We can split it. And then we can say that the given polynomial is equal to divisor into quotient plus remainder. Please understand here the divisor is of degree 2. So what is the degree of remainder? The degree of remainder, as we have seen already, will be less than the degree of divisor. So its degree will be less than 2. So the maximum degree of the remainder will be 1. So my general remainder in this case, which I can take, will be like ax plus b, something like that. So what I get is this given polynomial is equal to x minus 2 to x minus 3 into qx plus ax plus b. In this equation, if I put x as 2, my first term on right hand side becomes 0. It vanishes because x is put as 2. So the whole thing becomes like this. LHS is 33 by putting x as 2, and RHS becomes finally 2a plus b. So I will say 2a plus b is equal to 33. Let us say this is my first equation. Next, similarly, I put x as 3 in the given original equation. I will get finally 3a plus b is equal to 121. Let's call it second equation. And so solving these two equations, I'll get the value of a and b as 88 and minus 143, as you can see. And so my remainder is 88x minus 143, which seemingly is a little lengthy, but yes, different method than the conventional approach of division directly. There is a very good shortcut also for this question. So what is that shortcut? I can put x as 2 in the main function. The remainder I will get is 33. Okay. From the options, by putting x as 2 in the options, whichever option gives me the value as 33 is going to be my answer. And I realize that only D option gives me remainder value as 33 when I put x there as 2. No other option gives me that. And so in a very short time, I'm able to solve this seemingly lengthy question. Let's take one more application-based problem, and this is this. If the given polynomial is divided by this, remainders are 5 and 19 respectively, find the remainder when f(x) is divided by x minus 2. So how do I go about this? First, please notice that in the main function given, we are not given the values of a and b. These are unknown constants. How to find a value of these unknown constants? We'll make use of remainder theorem in this question. So we see that f of 1 is given as 5. It means by putting x as 1 in the main function, it should be equal to 5. That gives me first equation connecting a and b, and that is minus a plus b equal to 3. Similarly, f of minus 1 is 19, and so I get another equation that gives me a plus b equal to 13. That's second equation. Solving these for the values of a and b, I get a as 5 and b as 8. So my polynomial becomes x4 minus 2x cubed plus 3x squared minus 5x plus 8. And now the question is, this polynomial when divided by x minus 2, what is the remainder? So obviously it's now simple question. We can apply remainder theorem once again to get to the answer. So f of 2 is the answer, and that is finally 10. Okay. One more problem. Now how do we go about this? It looks like a difficult problem. Let us see some method available or not. Okay, so when I see this problem, first thing I want to tell all of you students is that please don't find a value of each term by using some kind of calculator or so, because that will be very, very lengthy. So what do? Observe that some terms are given as, intermittently I have given the terms as 361. And you should know that 361 is 19 square. So replace 361 by 19 square everywhere you see 361, we get finally this. Okay. Now replace 19 everywhere by x. So we get a polynomial in x. X to the power 8 minus 17, x to the power 7, and so on. Let's call it fx. So when you divide fx by x minus 19, what will be the remainder? Will the remainder not be the same which is question given? That is f of 19? Of course. Because by remainder theorem, we know that when you divide fx by x minus 19, my remainder is f of 19. And the main question given is nothing else but f19 itself. So basically, I am supposed to find out the remainder when I divide the given polynomial by x minus 19. And how to do that? We can do that by a synthetic method. So one put as it is in the answer, then 1 into 19 gives me 19, and minus 17 plus 19 get 2, and so on. I'm not elaborating any further. Finally, you get what? 41, and that is the remainder. And my question was this only, the expression is nothing but the remainder when the polynomial was divided by x minus 19. The remainder here we can see is 41, so my answer obviously is 41, that is B option. Okay, hope you like this. Now, is there a shortcut method to this? Of course, we have a shortcut method for this. In this shortcut method, what we do is, we realize that every term in the expression is divisible by 19 except the last number, which is plus 3. And here lies the hint. So when you divide the entire expression by 19, my remainder will be 3. Whichever option when divided by 19 gives me remainder 3 is going to be the answer. Now in this case, I realize that there's only one option, that is 41, which when divided by 19 gives me remainder 3, and so that is the answer. Of course, I realize that if there are two options given, both which when divided by 19 gives you remainder 3, then you will be stuck up with which of them is the answer. Then you have no choice but to follow the first method. Okay, but otherwise, normally examiners are not doing these kind of things in the questions. They give you only one such option, and if people are smart enough to identify that, they'll get it faster. Otherwise, they'll end up wasting a lot of time, or maybe students will leave such questions. Okay, let's try now one more problem, and that is the CAT 2019 problem. Find the largest value of n with this property. How do you go about this? I feel that students will be normally inclined to put the value of n from the options, and whichever is the largest of the option, which gives you the expression's value as integer, will be the answer. But that can be calculation intensive. Be a little bit more smart, and let's factorize. We see it is n plus 3 into n plus 4, the numerator part. Denominator is n minus 4 into n plus 3, and we see that n plus 3 cancels. We are left with n plus 4 upon n minus 4, which I can further write as, the numerator I can split as n plus 4 as n minus 4 plus 8. Denominator is kept as it is, n minus 4. Now split the two fractions. So what do I get? I finally get 1 plus and then 8 upon n minus 4. For this expression to remain a positive integer, the second term must be integer. And for that, n minus 4 cannot exceed 8. So the maximum value of n minus 4 will be 8, and that means the maximum value of n will be 12. And that is the answer. However, when we had obtained n plus 4 upon n minus 4 in the first step, at that stage also I could have used option, because now using options will be easier instead of using option at the first stage. So putting n as 6 or 16 or 12 or 8, we realize that the largest value of n will be 12, which when put in the expression will give me the answer as positive integer. Okay. Thank you for watching this video. In case you have any query regarding this video, you can always approach me on the mentioned email ID. Alternatively, you can also send the comments in the comment box.